Section 5.5 is completing the square. First, let's just practice using the square root property. The left side of this polynomial is a perfect square trinomial. It factors into two identical binomials, x plus 3 times x plus 3, which is the same thing as saying x plus 3 quantity squared. The square root property is undoing the square by taking the square root of both sides. And when you square a square root, what's inside just falls out. And anytime you're solving for x squared and you have to take the square root, you must give it a plus or a minus 6. Now subtract 3 on both sides, so that x is equal to negative 3 plus or minus 6. Now you need to separate that. So negative 3 plus 6, which is 3, and x is equal to negative 3 minus 6, which is negative 9. So those are your x's, also known as your roots, also known as your zeros, also known as your x-intercepts. Example B, solve using the square root property. I can see on the left side that is a perfect square that factors into, it's a perfect square trinomial, and it factors to x minus 6 quantity squared. Take the square root, what's inside just falls out, and you get plus or minus 5. Add 6 to both sides, so that x is equal to 6 plus 5, which is 11, and x is equal to 6 minus 5, which is 1. 1c, again, the left side is a perfect square trinomial. It factors into x minus 8 squared is equal to 49. Take the square root, so that's x minus 8 is equal to plus or minus 7. Add 8 to both sides, split it to say x plus 7, which is 15, and x is equal to 8 minus 7, which is 1. Now some roots that are irrational can be written in radical form or decimal form. And there's the 2 decimal units. So normally you would round to the nearest hundredths, but when you rounded the hundredths, because it was a 9, it rounded to the tenths place. Example 2, we're going to factor x plus 4 quantity squared is equal to 20. Take the square root, so that's x plus 4 is equal to plus or minus the square root of 20. Now I know that 20, I'm going to break that down to 4 times 5. So I'm going to kind of do a little of this mentally. Square root of 4 is 2, so that's 2 square root of 5. Subtract 4 on both sides, so that's x is equal to negative 4 plus or minus 2 square root of 5. Now let's split it, say negative 4 plus 2 square root of 5, and x is equal to negative 4 minus 2 square root of 5. Now use the calculator and get a decimal answer. You can then also put this in your graphing calculator, replace the, first you'd have to put it equal to 0. So that would be x squared plus 8x, subtract 20 on both sides, so you get negative 4 is equal to 0. And replace the 0 with y equals x squared plus 8x minus 4. And then the second equation is y equals 0. Put these two in, hit second function, trace, intersect, and then use your right and left arrow until the cursor is crossing over the x-axis and where the graph, and hit enter 3 times, and it'll give you the intersection. So play around with that on your graphing calculator, and you should get these two answers, one on the left side and then on the one on the right side of your parabola. All quadratic equations can be solved by using the square root property by manipulating the equation until one side is a perfect square. This method is called completing the square. The steps for completing the square: C needs to be a perfect square. And C right now is a perfect square, but if we go to factor it, it's got to be a perfect square trinomial, which would need to be a plus sign, and that would have to be a perfect square, which would then add up. If you double it, do you get the middle term? That is not the case with this 9. So that is not giving me, that is not a perfect square trinomial on the left side. So step 1, if C isn't a perfect square, you must get C on the right side. So we're going to get C on the right side by adding it. Now I'm going to leave a space and add 9. Step 2, take half of b and square it. B is the number in front of x. So 16, half of 16 is 8, and 8 squared is 64. So I am going to add 64 on both sides. Now this is a perfect square trinomial that factors into x plus 8 quantity squared. The way you could check that is, what's 8 plus 8? 16, which gives you the b, is equal to 9 plus 64 is 73. Now we're going to take the square root. So we get x plus 8 is equal to plus or minus the square root of 73. I cannot simplify square root of 73 down, so I am now going to subtract 8 on both sides. So it's negative 8 plus or minus the square root of 73. I am fine with you leaving it like that. You could split it to say negative 8 plus the square root of 73, and x is equal to negative 8 minus the square root of 73. If it doesn't say to round it, leave it in radical form. If it says to give some sort of approximation, then that would mean you would get a decimal answer. Example 3, find the value of C that makes each trinomial a perfect square. So all we're doing is just getting the practice of taking half of B, squaring it. So half of 16 is 8, 8 squared is 64, so C would be 64. Example B, half of negative 14 is a negative 7, and negative 7 squared is a positive 49. It will always be a positive, so whether it's a minus sign or a positive sign, it doesn't matter. The last sign is always going to be a positive. Example 4, solve by completing the square. I can see right away that 11 is not a perfect square. So I need to force the left side to be a perfect square. And to do that, I've got to get C on the right side. So I'm going to add C. Now I'm going to take half of 10, which is 5, square it is 25, and add 25 to both sides. So that's x plus 5 quantity squared is equal to 36. Take the square root. So that's x plus 5 is equal to plus or minus 6. Subtract 5 on both sides. X is equal to negative 5 plus 6, which is 1, and negative 5 minus 6, which is negative 11. Example 4b, 24 is not a perfect square, so I'm going to get 24 on the other side by subtracting it. Take half of 10 is 5, squared is 25. So that's x minus 5 squared is equal to 1. Take the square root. So x minus 5 is equal to plus or minus the square root of 1 is 1. Add 5 to both sides. X is equal to 5 plus 1, which is 6. And x is equal to 5 minus 1, which is negative. Which is 4. Now let's look at example example 4c, This 9 is a perfect square. However, when we double 3, 3 plus 3 is 6, not 10. So it is not a perfect square trinomial. So I'm going to get 9 on the other side by subtracting it. Half of 10 is 5, squared is 25. So that's x plus 5 quantity squared is equal to 16. Take the square root. X plus 5 is equal to plus or minus 4. Subtract 5 on both sides. So x is equal to negative 5 plus 4, which is 1, and x is equal to negative 5 minus 4, which is negative 9. I'm going to come back and do example 5 in a minute, but I want to skip and do a problem from the homework first before I do a problem like number 5. Okay, let's look at 39. X squared plus 4x plus 11 is equal to 0. Obviously, the 11 is not a perfect square. So we're going to move it on the other side. Half of 4 is 2, squared is 4, so we're going to add 4 to both sides. So that's x plus 2 quantity squared is equal to negative 11 plus 4 is a negative 7. Now we're going to take the square root. So that's x plus 2 is equal to plus or minus. Now that square root of 7, remember, you cannot take a square root of a negative number. You have to break it down to negative 1 times 7. And square root of negative 1 is I, so that's I squared of 7. So it's plus or minus I squared of 7. Subtract 2 on both sides. So you get x is equal to negative 2 plus or minus I squared of 7. I am fine with leaving it that way. If you want to split it to say negative 2 plus I squared of 7, and then negative 2 minus I squared of 7. Okay, number 41. This is not a perfect square, so I'm going to move the 29 on the other side, so I'm going to subtract it. Half of 10 is 5, 5 squared is 25. Add 25 to both sides. So that's x minus 5 quantity squared is equal to negative 29 plus 25 is a negative 4. Take the square root. That's x minus 5 is equal to plus or minus square root of negative 4 is 2i. Add 5. So it's x is equal to 5 plus or minus 2i. You can separate it to 5 plus 2i, and x is equal to 5 minus 2i. Okay, now let's go back and do example 5. Solve by completing the square. Now, something I have not mentioned, when you, to complete the square, x squared has to have a coefficient of 1. And this does not have a coefficient of 1, so we have to get rid of the 2 by dividing everything by 2. So that's x squared minus 7/2 x plus 5 over 2 is equal to 0. I'm going to get the 5/2 on the other side. So subtract 5/2. Okay, now here's where it gets a little complicated. We are going to take half of b. Go to the side. That's 1/2 times negative 7 over 2, which is negative 7 over 4. We have to square that. So that's 49 over 16. So we add 49 over 16 to both sides. Now, this is a perfect square trinomial. It doesn't look like it, but it is. It's x minus, and it's always the half of b. So go over here, it's that negative 7 over 4. Quantity squared is equal to negative 5/2 plus 16. You can use your calculator to help you to get this answer. Or you can go to the side and get it. So you get 9 over 16. Take the square root. So that's x minus 7 over 4 is equal to plus or minus. The square root of 9 is 3, and the square root of 16 is 4, so it's 3/4. Add 7/4 to both sides. I'm kind of running out of room here. So it's x is equal to 7 over 4 plus 3/4, which is 10/4, which is 5/2. And then x is equal to 7 over 4 minus 3 over 4, which is 4 over 4, which is 1. So there are the two answers. That's a little bit more complicated. Which leads us to doing number 35. Okay, we have to divide everything by 2. So that's x squared minus 3/2 x. Now I'm going to go ahead and subtract the 5/2, put it on the other side at the same time, because 0 divided by 2, that turns into 0. Okay, now go to the side and take half of b. So that's 1/2 times a negative 3 over 2 is a negative 9/4. Square it, that's 36 over 16, and that's what I add to both sides. So this is a perfect square trinomial. It's x minus, it's always the half of b. So if you go over here to your side work, it's the negative 9/4, or minus 9/4. Same thing. Is equal to, now, you can either use a graphing calculator or you can go to the side and add negative 5/2 plus 36 over 16. Now, it's a negative 4 over 16. I know that I can reduce that to negative 1/4. Take the square root, so what's inside just falls out. And that gives me an imaginary number which is I, and square root of 1 is 1, and square root of 4 is 2. So it's 1/2 I is really the right way to say it. And it's plus or minus. Now, you have to notice that you have when I go to add this, I'm going to have not the same denominator. So it might have been better to leave it as negative 4 over 16. So I'm going to go back and do that real quick. And that gives me square root of 4 is 2. Square root of 16 is 4. And it's an I. So now I still have a common denominator. So I'm going to add 9/4 to both sides. Okay, so that's x is equal to negative 9 over 4 plus or minus 2 over 4i. And yes, I could reduce the 2 over 4, but I cannot reduce the negative 9 over 4, so I'm going to stop right there. Okay, I'm going to add 9 over 16. I made an error, and I'm fixing my error. Sorry about that. So this is a perfect square trinomial, which is x minus the half of 3/2, which is 3/4. Squared is equal to negative 5/2 plus 9 over 16. I'm going to go to the side and get negative 31 over 16. Take the square root. So that's x minus 3/4 is equal to plus or minus. Now, I cannot take the square root of negative 31, so that's I square root of 31. And I can take the square root of 16, so that's 4. Add 3/4 to both sides. So that's x is equal to 3/4 plus or minus I square root of 31 over 4. Now you can leave it like that, or you can put it all over one denominator. Leaving it like that is just fine with me. That's the end of section 5.5, completing the square.